Hi, this video will provide you some examples of how you determine the returns to scale, using both the definition of returns to scale and show you another way to calculate it if you have a Cobb-Douglas production technology. So returns to scale, briefly, what is it? This tells you if you change your inputs by a given proportion, if your output changes by that same proportion, or changes by a larger proportion or a smaller proportion. Each of these three scenarios are possible. That will tell you the returns to scale. So, in the increase in returns to scale case, for example, if the proportion is a doubling of your inputs and your output correspondingly more than doubles, that's an increase in returns to scale. Decrease in returns to scale, you double your inputs, your output less than doubles. Constant returns to scale, doubling inputs, your output exactly doubles. In a previous video, I went through the Cobb-Douglas production function. This, if you have this technology where your labor and capital are multiplied by each other, then the corresponding superscripts added up will tell you the returns to scale. If they add up to 1, it's constant. If they add up to a number more than 1, it's increasing. If they add up to a number less than 1, it's decreasing. In this example, though, I'm going to show you both using the Cobb-Douglas production technology when we can apply it and using the definition of returns to scale to show you get the same answer. So, recalling the Cobb-Douglas production technology, you have superscripts 1/2 and 1/2. They add up to 1. So this is a constant returns to scale production function. Next, let's use the definition of doubling our inputs, what happens to our output, to confirm that it is indeed a constant returns to scale production function. So let's start out with our labor and capital both being 1. How much is output if labor and capital is 1? Let's see, we have 1 square root, that's 1. We have it multiplied by another square root of 1. So square root of 1 times square root of 1 is equal to 1 times 10. So this is an output of 10. Now we want to double our inputs. Let k be 2 and L be 2. So we've got the square root of 2 times square root of 2. That's the square root of 4. The square root of 4, of course, is 2. And 2 times 10 is 20. So, recalling that our output previously was 10, we double our inputs. Output now is 20. Our output doubled. This is why we have a constant returns to scale production technology. Let's try it now for the second one. Again, let your capital and labor both be 1. How much is your output? Correct, it's 10. Now, let your K and L both be 2. You've doubled your inputs. So you've got a 10 times 2, which is 20, times another 2, which is 40. So your output was 10, and now it's 40. You doubled your inputs, your output more than doubled, increasing returns to scale. Let's use that same approach for this third one. Let your capital and labor both be 1. How much is your output? That's 10 divided by 10 times 1 divided by 1. That's simply 10. Now, what if we double our inputs? So you have 10 times 2 divided by 2. It's still 10. Your output doesn't change. This is an example of a decrease in returns to scale production technology. Because your inputs have doubled, your output did not double. It less than doubled. It didn't change. Finally, let's do this calculation for this fourth one. Let K and L both be 1. How much is your output? It would be 12. Let K and L both be 2 now, doubling our inputs. Now we have 20 over here, and we have 4 over here. Add those up, that's 24. So output was 12, now it's 24. That's a doubling of our output. So this is an example of a constant returns to scale production function. One note about this last example. This is not a Cobb-Douglas technology for a production function. So you've got to use the definition in order to calculate this returns to scale. Items 2 and items 3 are Cobb-Douglas production technology, so you can use a superscript adding up approach to get you the same answer that we just drove.